Simplify in parentheses 2x to the third z squared, all of which to the third power, all over x cubed, y to the fourth, z squared, times x to the negative fourth, z to the third. All right. Lots to do. First things first, I have a parentheses taken to an exponent, and inside the parentheses, I have a bunch of stuff going on with exponents too. What I want to do is label all the exponents. So yes, I'm going to put an invisible one there. When you take a parentheses to an exponent, you distribute that exponent to every exponent here and multiply the exponents. So 3 times 1 becomes 2 to the third. 3 times x to the third becomes x to the ninth, and 3 times z squared is going to be z to the sixth. Now downstairs in the denominator, I have x to the third and x to the negative fourth. Let's group those together. X to the third, x to the negative fourth, right? I have y to the fourth and nothing else like it, so y to the fourth. Z squared and z to the third, let's group those. Z squared, z to the third. Now looking at this, what I see is I see one, and only one, negative exponents and a fraction bar. Go through all 1, 2, 3, 4, 5, 6, 7, 8 terms of this and see if your term stays or moves depending on whether it has a positive or a negative exponent. If it's a positive exponent, it stays. 2 to the positive 3 stays. X to the positive 9 stays. Z to the positive 6 stays. X to the positive 3 stays. X to the negative fourth moves to the top and becomes x to the positive fourth. Y to the fourth stays. Z squared stays. Z to the third stays. Now if you want to, you can rewrite this, and maybe I will, so that things are next to each other. So I notice that I have an x to the ninth and an x to the fourth. Why not scooch those next to each other? Because why not? Leave the z6 there off to the side where it belongs. I have x to the third, y to the fourth, z to the second, z to the third. If you have terms of the same base next to each other, deal with that first. 2 to the third is 2 to the third, leave it for now. X to the ninth times x to the fourth are terms of the same base. If you're multiplying terms of the same base, add the exponents, x to the 13th power. Z to the 6th, z to the 6th. X to the third, x to the third. Y to the fourth is y to the fourth. Z squared times z to the third are terms of the same base that are being multiplied together. Add the exponents and make it z to the fifth. Now we're not done yet, because I have x's upstairs and downstairs and z's upstairs and downstairs. 2 to the third is 2 to the third, leave it there. I have 13 x's in the numerator and 3 x's in the denominator. Whenever you have terms of the same base, right, and you're dividing them, find out which one's more powerful. X to the 13th is more powerful than x to the third. Leave it in the numerator, subtract the exponents, and call it 10. Okay? Similarly, I have z to the 6th power up here and z to the 5th power in the denominator. 6 is barely more powerful than 5, so leave z up there, and 6 minus 5 is invisible 1. Now you just have this y kind of living down here all by itself, so leave it. So let's clean this up a little bit, and I'm going to write this out 2 different ways because it all depends on your teacher and how they accept this. 2 to the third can stay 2 to the third for now. X to the 10th is x to the 10th. Z to the invisible 1 we'll just call z. Y to the 4th is y to the 4th. Many teachers would be like, that's perfectly fine. But a lot of teachers might be like, I don't know, 2 to the third, isn't that 2 times 2 times 2? And if your teacher's like that, you would just be like, all right, 2 times 2 times 2 is 8. So 8, 10 to the third, z all over y to the 4th. Both of these are the same exact thing. Both of these are acceptable. It all just depends on what you're trying to do and what curriculum you have. But at the end of the day, we end up with those answers, and neither one of those is technically correct.